We're good?
Yep, we're good. Wait,
All
actually,
right.
can you confirm if you can hear him? Room? Yes? No? Yes?
We can hear him. Yeah.
Perfect. Okay, then I will get started. Thank you everyone for showing up. I also believe I have a couple of my coworkers here, so they know how hectic the day has been. So welcome everyone. This is a talk on getting started in IoT research. It's really fun, it's exciting, and it's the coolest thing since Internet of Toasters. So I hope everyone has fun on this little talk. I would like to be able to click. Thank you. So the first question that you probably want to ask is, you want to be a hacker? And the answer is yes, of course you do. Because this is where all the cool things are. You too can get involved in IoT research. IoT research is actually fairly simple to get started with. A lot of competitions, a lot of work with CTFs gets you prepared for the work with embedded devices. And so this is an easy way that you can just actually get started and learn without actually buying equipment, because I know as a student, that's always a little bit of a challenge. 1 second. My computer decides to be weird the moment I start sharing my screen. So let's see if we can fix this. I am just switching my monitor out, so it does not glitch. Everything that could go wrong would go wrong, right? My apologies, guys. I actually rehearsed this and it doesn't seem like it. Okay, I want to present. Okay, there it goes. Yeah, it's the live demo curse, I believe. All right, so now I can see everything. Good. It was in a little tiny window before. So who am I and why do you care? I am a Cal Poly alumni. I have done a lot of different competitions. I was one of the first team captains for the CPTC team. I was team captain for 2 years for CCDC. I have been doing embedded research since 2014. I have spoken at DEF CON and Layer 1 multiple times on the topic of IoT, Internet of Things, and embedded security. I am also a Black Badge winner at DEF CON, and I have done actual research that has been published on protocols and hardware. For those of you who participated in CPTC, I was the designer of the embedded research system, the wireless research system that you had to manipulate. I am also one of the folks that is involved in the OMG crew. So if you've heard of the OMG cable and things like that, I'm one of the folks that helps make that happen. So fun times. So where do we begin with embedded security? Well, first, it has many names. If you didn't think of IoT or hardware hacking or embedded security, you're not wrong. There's a lot of names, and all of them are correct. So don't worry if you're not familiar with every one of the different technologies and things like that. There's also ICS research. All of these are various things that are basically across the same vein. If you start in one, you can easily transfer to the other. So don't worry if you don't know all of them, just start with one of them. And so what does this actually mean? If you've researched, for example, ATMs, routers, edge routers, voting machines, those are some pretty common ones. Power meters. If you've taken a look at, I don't know, if you have solar panels, you have a solar controller. Those are all embedded systems. In many cases, they're actually running an embedded operating system or a full-blown operating system such as Linux. You also have the full-blown computers that are part of embedded research, because a lot of times, especially in the industrial control systems realm, there's a full computer managing the embedded systems. Also, some other areas that are fun that you can do research and have just enjoyment in are kiosk escapes. This is where you have like a embedded system doing like digital signage stuff and you escape into the desktop. Got many stories on this one. I was at a museum once where I was able to do an escape and I actually had found someone else had already done the escape beforehand and they installed like backdoors on the system. And I was like, nope, don't want any part of this. So these are very common. These are not something that are hard to start learning about, but they also are a good way to get introduced into the lower level stuff because you can just mess with the kiosk and find out how it works. What do these systems use, especially the kiosks? Usually embedded Windows, but it's not always the case. Sometimes they're what's called RTOS or real-time operating systems. So how do you get started with this, right? Well, you have to have a love of tinkering, and then you have to actually find something that interests you. So in my very accurate tinkering pie chart, there is the chart of devices that are interesting to tinker with and the devices that are too boring to tinker with, and the value is 0. And the reason why is because there are no devices that are too boring. I have screenshots in here of a lot of different things. Like in this previous slide, I will answer at the end, but I'm really curious what people think this is. And if you know the answer, you can write it out. I don't have any prizes, but I'm really curious if anyone can figure it out. But the point is, the key for embedded research is curiosity. If you're not curious, you will not succeed. So develop that curiosity, and no device is too boring. But there are some rules. There are some things that you have to do to make sure that you do things securely and properly. So these aren't actual rules of the game. They're more fun. But the rules that we have are no embedded system is too locked down. This is at my work. We had a company team all hands, and we had these consoles that allowed us to control the TVs. So going through, I was able to get a YouTube escape and be able to play videos. So that was a lot of fun. And then there's other types of escape where it may be an everyday appliance like a phone, and you can still do some stuff. And this is a special dialing key to actually get control of the different advanced settings in an iPhone. Not every device has this because it's controlled in different ways, but a lot of them have these things. And then no system is too small to tinker with. I will also, again, give people a guess what this is, but I will, nobody's really, I guess everyone's in person, so they're not really typing on the Zoom message, so I will just answer it. This is actually a shipping thermometer. So when you have something that's temperature sensitive and you need to know if it's unsafe, this is that device. It's very simple, but because they have to do it in bulk, how are they doing the temperature sensing? So this was a very interesting one to me because it was so cheap. There's only one little IC on the top left, and the rest is just basically a button and some battery. So that was very cool to see and reverse engineer. And so I'm personally of the opinion that there's no system that is not something fascinating, because the more you take it apart, the more you're like, wow, they did this. A lot of embedded engineering is really good. There's some really bad embedded engineering where they do really poor designs, but a lot of embedded engineers really, really try really hard to make a good product, even if the software is insecure. So it's really cool to work backwards and see why things were designed. And then, of course, no system is too obscure to tinker with. This is my place. I got a ATM and a voting machine. And you can see the voting machine is playing the Illuminati, and the ATM is doing ATM things where I can make it spit out money. But where do you get started? It's great that you can look at all these devices, but how do you actually get in and start working with them? Well, there's the expensive things. Expensive things are fun, but they're not really easily obtainable. I don't know how many college students can afford $2,000 logic analyzers. So instead, we're going to go with some simple things. A multimeter is about 30 bucks, very important. A magnifying glass is about 20 bucks. A serial converter or a bunch, they're $10 to $40. and a soldering iron and tools and some probes and wires and things like that. You can get all of this for under $100 and have basically the toolkit. I have an actual whole Pelican case that's a carry-on that I take when I go to do actual research. This Pelican contains a whole lot more than this beginner guide. I can write down somewhere some of the stuff if anyone's interested. But essentially, you need to start somewhere. The list of things here is the starting guide, and there's some cheap logic analyzers. I have a series of pictures of them in the right. That's a knockoff Saley Logic, and you can use that for about $20, and it gets you a good starting point. It's not great, but also if you fry it for $20, it's not a huge issue. So some more expensive tools, a LimeRF or a HackRF. I really recommend against a flipper for this because a flipper is great at replaying and it's really easy at replaying, but you're not analyzing the protocol. You're not really when you do a replay attack, you're doing something already known. You don't actually gain understanding of what's going on inside. You can capture signals and replay them, but you want to know how something works, you're going to do it by hand. And be able to transmit at different or higher bandwidths. And that's where these software-defined radios really come in. And then, of course, you're going to want a travel router. A GLINet is a really good one. They run openwrt, and they've been really good at building reliable devices that still work way down the line. Okay. And then, of course, we've gotten all the basic kits. So where do we go from here? The next step that you want to do when you're looking at different things is you've got the probes, you got the hardware, but maybe you don't. If you don't have the hardware and you don't have that, you can still get an idea of the board layout by going to the FCC ID. If it has a wireless device in it, it has to have an FCC ID. So you can go to the FCC ID IO website and click external photos or internal photos. And this will show you the device, the pinouts and stuff, in some cases in better fidelity than what the actual like breaking it open shows you. Because when you crack a device open, especially something with a radio, they usually have shielding. And those prevent you from actually looking deep down at the device or getting to serial ports. So when they have to do an evaluation, they have to actually go in and do detailed analysis so that they pull all those shields off and you can actually see the underlying surface. You'll then want some software. Again, once you have and if you have something physical, this is PulseView, which paired with a logic analyzer will allow you to see the actual signals being sent. It has a number of pins, so you can actually read multiple pieces of data at boot and dump it, and then get the data back and be able to actually, see what's happening. And then finally, the other one that I love is Ultimate Radio Hacker. It allows you to analyze signals, OSK, FSK, and PSK, and see who's talking and build patterns for being able to replay and then also modify the signals. And you can see the breakdown on the left side of the signal, so where you can actually tamper with it. For IoT, if we're going to get our hands on stuff, you can get some easy access to some fairly cheap stuff. Cameras and routers for home use mostly run Linux. That means they usually have a serial port that's accessible. Some are very out of date and they're still sold, so they have a lot of vulnerabilities you can get into. Good way to start with this. And then a lot of systems, especially like the MyCloud, I think that's been finally discontinued, but there's still plenty available. It's actually running Debian, just a broken version of Debian. And so they actually can see, you can actually see in there how to get it working, and you're actually running a full environment and mess with it. So that's a fun one. Finding interfaces though is a challenge. Sometimes they're in plain sight. The top one is actually a RX and TX pad, plus a bunch of other stuff that I believe is JTAG. I forget. I'm pretty sure it's JTAG though. So you can actually connect the stuff or solder onto there and actually read the data of the microcontroller when it's starting up. And then the bottom one is actually my remote control for my TV. You can see what TV I actually have on there. That's pretty fun. Don't hack me. But you can see that the TV is actually a smart device and it has a serial interface to the actual microcontroller on it. So you can connect and read the data as it boots. And this is what I talk about. No embedded system is too basic because the remote control is actually probably running some embedded operating system that, and maybe even Linux to do its button pushes. And then there's of course other novelty things. When I was a student, I participated in some research that was for drones, and we had the Parrot drones. These are pretty well docked on how insecure they are. They have a full Linux userland. It turns out they only have security if you use their phone app. If you don't ever engage the phone app, it doesn't turn on the firewall, so you have an open telnet interface into the drone. And it supports booting from USB, so you can actually create a whole another user land and run. And it had like 512 megs of RAM, so it was fairly beefy, and you could directly interface with the device. This is going to be this is a camera, but what I would like to do is have people to try to identify some interesting test points on here. I can see them, but I would love to see others and see if they can identify the different components. From my view, I can see RAM, I can see the microcontroller, I can see a Ethernet magnetic chip. I can also see probably a SPI flash and a driver for the motor. But what else? Well, there's a bunch. You can test points usually come in pairs of 4, usually for serial. And so you can see me using the little jumper clips to connect to here and testing if it works, and the serial in the background. And then of course there's the where you solder it directly in. And so there was me finding another test point. So you can use a lot of different tricks to get control. And once you have the serial connection, you can do pretty much whatever you want. And then of course, this has been so far about getting into embedded devices, but I've seen the industry change mostly for the better. The first talk I gave on IoT was in 2015. Since then, a lot of vendors have gone out of business, thankfully, or not thankfully, I don't know. And a lot of products that were just super insecure are gone. A lot of the new stuff has a lot more security where they have like AB firmware where it's signed encrypted and it'll only swap over to the primary or the secondary if there's validation. So you can't just overwrite it and hope it'll work. It'll block it and restore to its safe state. Because of this, a lot of research has gone to mobile apps because the APIs that the phones are using aren't very secure. Sometimes it's the direct connection to the device or it's to the cloud itself. And the cloud has a lot of insecurities still. But there are still too many just smart enabled devices that are neither good at their original purpose and not very secure. So it is a problem. It's still not fixed, but it is getting better. And there's things like Matter, which is a new security protocol. Well, it's a new IoT communication protocol that is a lot more secure and seems to help eliminate the various interfaces, because if there's a standard interface, it can be audited more, and we seem to be getting there. Oops. And now coming back to the other side of the IoT devices is the industrial systems. These are ones that we don't usually get to play with too much, but it's ICS or SCADA, and these are, I've filled out the acronyms there, but basically these systems control heavy, big machinery. You'll often see these on Shodan when they shouldn't be connected to the internet, but are. Programmable logic controllers allow interfacing with computer systems to physical systems. like pumps and things like that. And most use something called Modbus. Modbus used to be over a serial network, and it also now supports over IP now. So there's a lot of communication over things that shouldn't. These control systems usually connect to something called a human management interface, which is like a screen for interfacing with things. Um, Putting wrong data into the controllers because they accept data as that is designed, they presume in most cases that they're on a secure network, and so someone telling you to turn something on or off is secure and should be trusted. If you turn on and off certain things without proper understanding, you can trigger a lot of dangerous things, which results in sometimes catastrophic results, where you can have systems shut down that are for safety systems. I remember a few years ago, there was a water treatment plant where there was a hack, and the sewage lines almost mixed with the freshwater lines, if I remember correctly. So securing these systems and finding vulnerabilities is super important. And then finally, there is what's in cars, which is the CAN bus. It's controller area network, but I've also seen a lot of people say car area network. I'm not gonna, you know, judge on one way or another, but essentially the controller area network is a protocol similar to RS-485, where it's designed to control the interfaces to all the different components of the car. You have your car computer, which communicates to the display unit, which also communicates to the motor and the door locks and all the other things. Interfacing with this network, you can actually modify a lot of signals and send your own. And the protocol is essentially very binary, but you can see here someone taking a frame, and all of these different packets can control what the car is seeing. And here's a diagram of some of the stuff. There's a lot of different systems, and you can see there's actually CAN bus, LIN bus, ASRB bus, and flex relay bus in most cars. These systems are interdependent, but in many cases, they connect to a central system, which communicates to the other systems. So, for example, the airbags are on their own safety network, but they also communicate to the car computer. So when something goes wrong, it can receive signals or send signals to trigger different things. So just because they're on their own networks, they're often, coupled together. So you may be asking, how do I get started? Well, you probably don't have thousands of dollars to build your own factory, but ICS simulators can help. There's one called ICS Sim. ICS Sim is pretty good. You can buy some cheap things. This one is a cheap water flow meter connected, and so you can actually read the 485 data. There's other devices online that you can buy that are RS-485 to get an idea, but you can go to ICS Village at DEF CON or Car Hacking Village or Aerospace Village and start actually messing with these things. Kiosks are another fun one. They're usually everywhere and run Windows. The security in most of these systems is the presumption that the kiosk cannot crash. So if you escape the kiosk, then you can get in. And for this, there's also these things like the Door King. Those are known to be very vulnerable. Those are also essentially, for the sake of this talk, kiosk systems. And then remember how I was saying about the system that was already owned when it was kiosk escaped. Here's a picture of that. You can see they had Netcat installed and a bunch of networking drivers. I will presume that that's the IT staff, right? So not necessarily really good. And then of course there is voting machines. I have done a lot of research on voting machines. There's Voting Machine Village at DEF CON. I've had a chance to work with some of the newer machines as well, but essentially these are embedded Windows systems or Linux systems. And so you can do a lot with them. A lot of the designs around these systems is Windows CE on the older ones. So you can actually make them do a lot of different things. Here's one doing NANCAT. And you can see there's the access port was obscuring an Ethernet port. And so when you pop off the label, you actually have access to another interface. So those are some interesting areas. And then of course there's ATMs. Most ATMs these days run a secure Windows embedded system environment. Some don't. I've done research on ones that don't. I've actually worked on an ATM processor for the underlying protocol. So the ATM thinks it's doing a valid transaction, but instead it's actually getting tampered with. So if you've been at CPTC, you may have heard about this one. And so she's putting in her PIN by just typing some numbers, and the screen is showing the live view of the actual ATM processing, or the processor intercepting the ATM data. And so in a second, it takes a while because it's actually going over dial-up. So it's actually intercepting the phone calls. And then it will process the data any second now. You'll see the screen will slide. There it goes. It processed the data, and then it's going to dump out money for her. So this is some of, oh, I don't want to see that video again. So there's a lot of different areas you can look at. I hope this talk has given you an opportunity to take a look and see at different areas that you can explore. But the end result is there's a lot of tools, there's a lot of devices, and you can actually get started on a college budget. But the main thing is always be curious and tinker. Here's my Twitter/X, my Mastodon. I also have Blue Sky nowadays because everything's, all funky. But I am happy to answer questions if anyone has any. I don't know if there's a way for people to show their in the room to ask questions, but what types of vulns do I usually look for? Well, there are usually when I go look at a new application, I look for getting shell onto the system and then look at the running daemons because usually there's like a web service and it's not very secure. So I will start those. And then the other question was why do ATMs run on Windows? Windows is not inherently insecure. The reason why they run Windows is because the software is easy to develop and test in Windows. And when you're running an embedded version of Windows, it's as open or insecure as possible as the developers make it. Banks have an incentive to make sure that it's secure, more secure. It's not that it's not without risk, but because the entry point is usually the applications, it's the application vulnerabilities that are going to get you anyway. So if it was on Linux, I don't think it would actually be any better. I have a friend who actually does for a living pen testing on ATMs, and he's seen a lot of vendors switching to Linux, but still the application vulnerabilities are the thing that they go after. I'm not sure that you can have negative hardware knowledge. The question is, as a person with negative hardware knowledge, I'm curious, what is the methodology involved with tinkering with the device? So to start tinkering, usually the best way to do it is start small. If I were to mess with a device and it was cheap, I would get again, the GLINet routers. You can connect to UART on those, you can dump the flash and stuff like that, and it costs $35. So with that plus the logic analyzer and a serial adapter, you can actually do a lot and get familiar. And most of it involves just taking probes and analyze and seeing what the different data or signals come back. If you have like a probe as a multimeter and you see that there's voltage or the different levels of voltage, and give you an idea. For example, if you see 5 volts, then it's usually just a power line. But you can actually start learning with those things and experimenting and seeing what works, because the way I learned was a lot of magic smoke. I don't know if that's the recommended way, but that is the way I did it. And you tinker and start learning. I don't know what um what companies pay you to do pen tests for ATMs. I know my friend's company. I will leave that off of this though, because I don't have permission to share his company. But there are companies that do that. I don't know of all of them, but basically a lot of pen testing companies do hardware research. Um, and so those are areas where you can get involved. Bug bounties are also a good way to get involved, because there's a lot of companies that want to find vulnerabilities, and work through those things. But as far as any given company, you can, when you're looking through their list of things that they do, that would be an area that you should definitely focus on. I don't work in embedded research. This is all a side hobby for me. One that's developed into a very expensive side hobby. But essentially, I by day do software security and by night hardware hacking. So you don't have to do this full time. If you do, definitely, power to you. But my point of this talk is to help people get started, not necessarily, determine your career. And yes, NCR Diebold, yes, all of those do have in-house ones, especially after they get hit at DEF CON by bad publicity. They definitely usually get a security team. And I can tell you from experience, a lot of the vendors that have been hit have made security a priority, which has been a nice thing to see. Um, Next question is what type of information can you get from tinkering with the tools you mentioned? With a logic analyzer, you can see what signals you can dump the flash. Once you dump the flash, you can get the firmware using a tool like binwalk. And when you use a tool like that, once you've dumped all the data, all those things are just basically executables. They're software, so you can, from there start looking at configuration. My favorite thing is when you get onto a new UART on an embedded device. There was one device that it was an IoT security firewall. The TTY was secured, but it had an API key for a Ubuntu cloud. And so the exploit was we signed up for the Ubuntu cloud and registered the device, and it downloaded an SSH key into root. So even though we didn't originally have access to the device, because they didn't secure the startup sequence, we were able to insert a root key into it. And once the root key existed, we were able to log in and it started up SSH for us. So there's weird ways to get into things. And then looking at their config, that turned out the password was like password 1234. So you see things like this where it's like they go through a lot of security, but they've forgotten a few steps. And so finding and reporting those things is fun for me, and that's where I enjoy. But there's a lot of other things, from Serial, you can get the console, which is basically using Linux and things like that. Next question. Did you do any work related to internships? I had different internship every year while I was at Cal Poly. I don't know that I would recommend that. It was a lot of work. It was a lot of different things, but I did get to find out areas that I liked and wanted to work in. Of course, once I graduated, I did not actually end up working in any of the things that I did internships with. But um, at least not where I am now. I bounced around a lot. But if you can get an internship, it's definitely recommended. It's definitely a good thing for experience, and also just finding out what you like. And the next question, how did you end up getting into your job that involves this hardware type of work? My job does not involve hardware work, whatsoever. It's software security. Um, so this stuff, all of the stuff that I do is just things that I enjoy. I do this on my spare time and work through it. My day job is very different than this talk. Um, any other questions or things like that? I don't know if there's anyone in the room that wants to ask questions. Yeah, and maybe I'll give another talk on actually doing some of this stuff, from getting into a system like a JLInet and then dumping the firmware, using binwalk to extract configuration, and then going from there. That's fairly advanced though, so maybe that's something for Tech Symposium, but it's definitely something that would be fun, I suspect. I am not a car hacking person. I am an IoT hacking person. I included that. Well, and I guess ATMs and voting machines. Car hacking is the one thing that I do not do. And the reason being is because I've just not had a lot of exposure to it. It's something that I would love to. I have a CAN analyzer, but you know, you have to either buy some old car components or things like that. So I haven't really had a chance to do it, but I will keep that in mind in case I find someone who does car hacking and is willing to come and give a talk here. I'm sure everyone would love that. But I can give you an IoT hacking live demo someday. It just has to be a little more in depth than a 40-minute talk. Well, based on this clock, it's almost 12:50. So unless anyone has anything else, thank you guys for having me. Sorry being a little bit late and having the meeting overrun, but it happens once you graduate. Yeah, thank you again. Feel free to send me messages. I am on Discord. So if you have questions, feel free to message me. And otherwise, have a good rest of your guys' day.
Thank you, Wasabi. This this Friday we have a workshop, or not a workshop, we have a presentation with Nazar here about social engineering. That'll be at 4 to 6 at the same room, I think. Yeah, and also apply for e-board applications or e-board roles, yes. All right, thank you, everyone.